Section 5.3, Solving Quadratic Equations by Factoring. Example 2, factor GCF or by grouping. In example A, we're going to look to see if we have a common factor, which we do. And our greatest common factor is 8x, so we are going to pull out the 8x. After we pull it out, we divide the GCF into each term into the binomial. 8 goes into 16 two times, and x goes in x squared. What we should do is think of it as x squared divided by x to the 1 power. And when we divide variables, we subtract the exponent. 2 minus 1 is 1, so it's x to the 1 power, or you could just say x. That is a plus sign, bring down the plus sign, and 8x goes into 8x one time, so we put a 1 and close the parentheses. To check this, we could distribute it back out, and when we do that, we get 16x squared plus 8x, which is the problem. So we know we factored out correctly. Example B, I'm going to factor out a GCF of 5. And remember, the GCF of the variable is the smallest exponent. So I have an x and a y. Now I'm going to divide 5xy into each term. 5 goes into 20 4 times, and x goes into x squared, x to the 1 power, or just say x. And then y goes into y one time. So I don't have to put the 1. Bring down the minus sign. 5 goes into 15 3 times. X goes into x one time. Think of it as this. X over x is 1. But 1 times 3 is 3, so we don't need to put the 1. And y goes into y to the second. That's a y to the 1 power, or we can just say y. Example 2, when you have 4 terms, you are going to factor by grouping. The steps for factor by grouping is you group the first 2 terms together and the last 2 terms together and make sure you have a plus sign in between. So I'm going to put a parentheses around the first 2 and a parentheses around the last 2. And then factor out a GCF from each group. In the first group, my GCF is x. Because remember what I said, it has to be the variable with the smallest exponent. There is nothing else to factor out. So I'm kind of looking at this and seeing that there's not really a big common factor in a lot of terms. However, if I switch these 2 around, I might have a better chance of factoring out more things. So that's what I'm going to do. Okay, now I'm going to group the first 2 together and group the last 2 together. And I have more things that I can factor out. I can factor out a 7 and an x. 7x goes into 7x squared x times. Plus 7 goes into 14 2 times. The x goes into x evenly 1 time, so I don't have to put a 1. And I don't have anything to divide the y with, so I have to bring it down. Bring down the plus sign. Now my GCF in the second group is a 6y to the second. Remember, it's the variable with the smallest exponent. And the only thing I have left over is x plus 6 goes into 12 2 times. Y squared goes into y cubed. Again, I should be picturing y to the cube divided by y squared. And when I divide, I subtract the exponents and get y to the 1 power, or just y. Now look, these 2 groups are the same. So now I'm going to factor that group out, which is the entire group, so they become 1. Kind of drag it out. I like to put a line through it so that I can visually see what's left over. And what's left over goes in parentheses, 7x plus 6y squared. So here is a binomial times a binomial. I could check by foiling these 2 out to make sure I get the original problem. Factor by grouping. Again, make sure you have that plus sign in between. I'm going to pull out, I don't have a common factor, So I'm going to look around, and I think maybe what I need to do is rewrite this, switching the second and the third term together. So that's what I'm going to do. Okay, now I'm going to group the first two together and the last two together. My GCF is AB. Now AB goes into AB evenly, so you have to put, if everything goes away, you have to put a 1. Plus, I don't have anything to divide the 4 with, so I have to bring it down. And A goes into A squared, A to the 1 power. And B goes into B evenly, so I don't put anything down. Close the parentheses, bring down the plus. My GCF is 3CD. And once again, 3CD goes into 3CD 1 time, plus 3 goes into 12 4 times. I don't have anything to divide the A with, so I'll bring it down. And the CD goes in CD evenly. Now, always look to make sure when you factor by grouping, if these two groups are not identical, you know you've done something wrong, which they are, so I am going to drag that out. They become 1, and what is left over? AB plus 3CD. And once again, I could check by doing the FOIL method. Example 2. Remember what I said about factoring by grouping. When you group the first two together and the last two together, you have to have a plus sign. Well, if you notice, there's a minus sign in between the two groups. So we have to add a plus sign. So I'm going to rewrite it, putting the negative with the 7G and adding a plus sign. Now I'm going to group the first two together, group the last two together, and notice that that negative goes in with the 7G, so I added a plus sign. Now my GCF is a 9F, and I get G minus 5. When your first term is a negative, you have to factor out a negative. So instead of writing plus a negative, I'm just going to say minus 7 is my GCF. And when you divide, negative goes into negative positive times, negative 7 goes into negative 7, positive 1, negative G, and negative 7 goes into positive 35, a negative 5. Now notice, again, these two are identical, so they become 1, so I'll factor that out. And what is left over? 9F minus 7. Now, just as a quick review, I am going to FOIL these two out. This is my answer, but we also need to check by FOILing, which is multiplying the first two terms together, then multiply the outside terms together, the inside terms together, and the last. So when you do the FOIL, the first, that's G times 9F is 9GF, or FG. My outside terms, this is my outside two terms. G times a negative 7 is a negative 7G. Then my inside terms, negative 5 times 9F is a negative 45F. And my last, negative 5 times a negative 7 is a positive 35. And if you'll notice, that is exactly what you have for the problem. The two middle terms are reversed, but that's okay. Example 3, this is a trinomial that you will factor into two binomials. So I'm going to make my two binomials. Look at the trinomial, the last sign. If the last sign is positive, then the signs in the binomial are both going to be the same thing. They are either both going to be positive or they're both going to be negative. And you look at the first sign to tell you what they're both going to be. So they're both going to be positive. Now this trinomial, the first term is a perfect square and the last term is a perfect square. So it's called a perfect square trinomial. So factors of x squared are x and x. And factors of 64 that are the square root of 64 is 8. So 8 goes in the back of each binomial. You can check to make sure you have the middle term. You don't have to check the entire FOIL method. You can just check the outer and the inner. The outside term is 8x, and my inside term is 8x, which is 16x, and that is my middle term, so it is correct. Now, x plus 8 times x plus 8 is the same thing as saying x plus 8 quantity squared. Example B, the very first term is a perfect square, and so is the last term is a perfect square, so I'm thinking it's a perfect square trinomial, which factors in the two identical binomials. Let's look at the signs. The last sign is positive, so that means they are both going to be whatever the first sign is, which is negative. The square root of 4 is 2, so I'm thinking it's going to be 2x in the front of each binomial, and the square root of 9 is 3, so I'm going to try that first. You always have to check to make sure you get the middle term by checking the outside, which is negative 6x, and my inside is a negative 6x, which is a negative 12x, and that is my middle term. So yes, it is a perfect square trinomial. You could also see it written like this, 2x minus 3 quantity squared. Example 3, C, that is, the middle term is missing. These are special binomials. They are called difference of two perfect square. They factor into opposite binomials. Think of the minus sign in between the two terms is the last sign, what gives you a negative answer, a positive and a negative. Square root of x squared, x and x. And the square root of 16 is 4 and 4. So when you multiply these two together, doing the FOIL method, let's go ahead and do the entire FOIL method on this one. X times x is x squared. My outside term is a negative 4x. My inside term is a positive 4x. And my last is a negative 16. So notice that my two middle terms go away. So we get x squared minus 16. Example D, that is a difference of two perfect square. That factors into 9x plus y. Now look at the y to the 6. Y to the 6, the perfect square of y to the 6 is y to the third times y to the third. Because remember, when you're multiplying variables, you add the exponents. So that's 9y plus y to the third times 9x minus y to the third. You have to know your perfect squares. Example 3e, 36 and 64 are perfect squares. So this looks to me like a difference of two perfect square. However, you don't forget to look for a GCF. And there is a GCF that goes into 36 and 64. The greatest common factor that goes into 36 and 64 is 4. So I'm going to factor that out first. 4 goes into 36 9 times. Can't do anything with the a squared, bring it down. Minus, and 4 goes into 64 16 times. And you get y to the fourth. Now that is a difference of two perfect square. So bring down the 4 and then factor that out to 3a plus 4y to the second, because y squared times y squared is y to the fourth, times 3a minus 4y to the second. Example F, I'm going to factor out a 3y is a GCF. Again, always look to see if you can factor out a GCF first. 3 goes into 75 25 times. Bring down the x squared. Y goes into y evenly. Minus 3 goes into 27 9 times. Y goes into y evenly. Now look at this remaining polynomial. That is a difference of two perfect square. So you bring down the 3y and factor into 5x plus 3 times 5x minus 3. And that is your answer completely factored. To check this, let me multiply. It doesn't really matter which which factors you multiply first. I'm going to go ahead and multiply the two binomials together doing the FOIL method. 5 times 5 is 25x squared. My outside term is a negative 15x. My inside term is a positive 15x. And my last is a negative 9. Combine my two middle terms, which go away. Bring down the minus 9. Now, don't forget, I now have to bring down the 3y, and now I'm going to do the distributive property. And I get 75x squared y minus 27y, which is the original problem, so I know that I factored correctly. Example 4, this is a trinomial. First, look to see if you have a GCF. There is not a common factor in all three terms, so I am going to factor into two binomials. So make my two binomials. First thing we have to determine is what the signs are going to be. The last sign is positive, so that means they are both going to be whatever the first sign is. So they're both going to be negative. Now in this problem, we have more factors than we have a number in front of y squared. So we have to list the factors of 6. 1 times 6 and 2 times 3. So we have some choices here. We can either use the 2 and the 3 or the 1 and the 6. And then the factors of the last term, 20, 1 times 20, 2 times 10, and 4 times 5. We have some options too. We can either use the 4 and the 5, the 2 and the 10, or the 1 and the 20. And I'm not sure which ones to use. So we are going to do what's called a guess and check method. I usually start at the bottom and work my way up. So I'm going to try 2y and 3y in the front of each binomial. And I'm going to try the 4 and the 5. And I'm just guessing. I'm going to put the 4 here and the 5 here. Now you have to check. You don't have to do the entire FOIL method to check. All you have to do is the outer and the inner. So my outside is a negative 10y. My inside is a negative 12y, which is a negative 22y. And I want my middle term to be a negative 23y. So that does not work. So I'm going to flip the 5 and the 4 around. You could have flipped the 2 and the 3, but you can't flip both. So I'm going to put the 5 here and the 4 here. Now to check, my outer is a negative 8y, and my inside is a negative 15y, which is a negative 23y, and that is my middle term. So that is the two binomials. Again, you could check by doing the complete FOIL method, but all that's really necessary is the outer and the inner. Example 4b, again, look to see, can you factor out a GCF? There is no GCF. It is a trinomial. I'm going to look to see if I can factor into two binomials. The last sign is positive, so that means they're both going to be whatever the first sign is. They're both going to be negative. Factors of 15. I can use 1 and 15 or 3 and 5. Factors of 1 or 1 and 1, so I have no choice but to use 1 and 1. But in the first term, I've got options. I can either use the 3 and the 5 or the 1 and the 15. I always like to start at the bottom and work my way up. I'm going to use the 3x and the 5x. Check, my outside is a negative 3x and my inside is a negative 5x, which is a negative 8x, and that is my middle term. So I factored correctly. Example 4c, look to see if you can factor out a GCF. There is no GCF, so I'm going to make my two binomials. Look at the last sign. If the last sign is negative, your signs are going to be different. One's going to be positive, one's going to be negative. Really doesn't matter which one you put is which. You could put the negative in the first binomial, positive in the last. It does not matter. Factors of 2. I don't have any choice but to use 1 and 2. So 1m and 2m. And again, you could use that as just m. 1m is the same thing as m. So you don't have to have the 1 there. You could have also put the 2m here and the 1m here. It really doesn't matter. I'm just taking a guess. Now 18, factors of 18. List the factors of 18. 1 times 18, 2 times 9, 3 times 6. I'm going to guess. I am going to try the 3 and the 6. Now I'm going to check. I do in the outside term. That's a negative 6m. The inside is a positive 6m, which is 0. My middle term is a negative 9. So that does not work. I'm going to switch the 6 and the 3 around. Now let's check it. My outside term is a negative 3m, and my inside is a positive 12m, which makes it a positive 9m. But look, I need it to be a negative 9m. When you have the same middle term but the wrong sign, all you do is switch the signs. So I'm going to make this negative a positive, and I'm going to make this positive a negative. Now, let's check again. My outside term is a positive 3m, and my inside term is a negative 12m, which is a negative 9m. And so that is my middle term. Number 31. It says to factor. First thing I'm going to do is look for a GCF. I have a GCF. 3 goes into 18, 3 goes into 15, and 3 also goes into 12. So I'm going to factor out a 3. I don't have a variable. I have an x squared in the first and x, but there is no x in the second, in the last term. So I can't factor out an x. 3 goes into 18, 6x squared, plus 3 goes into 15, 5x, minus 3 goes into 12 4 times. Now, this remaining trinomial, I have to factor in 2 binomials. So I'm going to make my 2 binomials. You can go ahead and bring down the 3 and then ignore it. We're just looking at focusing at the trinomial. Factors of 6. 1 times 6, 2 times 3. Factors of 4 are 1 and 4, 2 and 2. First thing I do when I'm making my 2 binomials is determine what my signs are going to be. The last sign is negative, so my signs are going to be different. One's positive, one's negative. Now comes the guessing part. I always start at the bottom and work my way up. Very rarely is it the number 1 in the factor itself. So I'm going to try the 2x and the 3x. And I'm going to try the 2 and the 2. So now let's check it. My outside term is a negative 4x, and my inside is 6x, which is 2x. That is not my middle term. I want my middle term to be 5. So that doesn't work. Now normally, I would just switch these two factors around, but because they're the exact same numbers, that's kind of pointless. So I am going to scratch out the 2 and the 2, and I'm going to try the 1 and the 4. I'm going to put the 1 here and the 4 here. My outside is a negative 8x. My inside is 3x, which is negative 5x. My middle term is a positive 5x. So this is very simple. I just changed my signs. Make this a positive and make that one a negative. Now to check it, it's 8x minus 3x, which is positive 5x. So this is my complete answer. Again, don't forget to bring down that 3. That is part of your answer. Number 35, look to see if you can factor out a GCF. 3 goes into 15. 3 goes into 84. I think it does. It does. 28 times. And 3 goes into 36 12 times. There is no common variable, so it's just a 3. So I'm going to factor out a 3 and get 5x squared minus 28x minus 36. Oh, excuse me, minus 12, because I had to divide. 3 goes into 36 12 times. Now, I'm going to look at this trinomial, make that into 2 binomials. My signs are going to be different. Factors of 5. Well, I don't have any choice but to use 1 and 5. You could either write 1x or just x is fine. You could put the x in the front of the first binomial and the 5x in the front of the second binomial, or you could reverse it. We're just guessing here. Factors of 12. 1 times 12, 2 times 6, 3 times 4. Again, I'm going to start at the bottom and work my way up. And I'm guessing. I'm going to put a 3 here and a 4 here. So my outside term is a negative 4x. My inside is 15x, which is 11x. I want a negative 28x. That is not negative 28x. So that does not work. I'm going to switch the 4 and the 3 around. Don't forget, before you delete it, you need to flip them. So I'm going to put the 4 here and the 3 here. My outside is a negative 3x. My inside is a positive 20x, which is 17. Nope, that does not work. So now I can scratch out the 3 and the 4. Now I'm going to try the 2 and the 6. My outside is a negative 12x. My inside is 10x. That's negative 2x. That does not work. So now I'm going to switch the 6 and the 2 around. So now my outside is a negative 2x. My inside is 30x, which is 28x. I need a negative 28x. So I'm just going to switch the sign, make that a positive, and make this one a negative. Now let's check once again. That's 2x minus 30x, which is negative 28x. Now don't forget, what did we forget? We forgot to bring that 3 down. Do not forget. It is part of the answer. If you forget to bring it down, it will be wrong. And that is the end of section 5.3 part 1. There will be a part 2 video later. Thank you.